Let's start properly. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
So you can hear me, but it's a bit, but with a little bit of echo. Is that so?
No, it's fine. Fine for me.
Oh, it's fine for you. Kalau saya cakap macam ni, dengar tak? Jauh sikit. Saya tak payah di depan saya. Dengar tak?
It's fine. It's fine. It's quite clear. It's enough.
Okay. To those who cannot hear me, I think you need to increase your volume. Okay. Yang tak berapa nak clear tu, kamera saya pun ni pun dah habis, dah letak lampu dah pun nampak macam ala-ala sama, right? The camera is not as good as the, I think as long as I can see that I'm still living, it's fine. Okay. Alright, so Alhamdulillah, Alhamdulillahirabbil alamin, wassalatu wassalamu ala asyrafil anbiya'i wal mursalin wa ala alihi wa sahbihi ajma'in. Kita kena banyak-banyak bersyukur dalam hidup ni. Sometimes we take many things for granted. When Allah give us any tribulation, any ujian, barulah kita macam nak bersyukur dengan semua yang kita ada sebelum tu lah. Sebelum ni tak pernah pun nak kata terima kasih laptop for working. But now when this happens, right, now you realize that you should be grateful. That's why in life Allah akan bagi kita ujian demi ujian. Sebab kalau tak kita akan hanyut dan lupa diri. Itulah. Kalau tak jadi macam ni, saya kalau lecturer yang semua smooth kan, dia kata I don't understand why student ni hang lah, tak boleh masuk lah, video tak okay lah, camera. So that's why in life Allah gives ujian so that kita, satu, untuk kita memahami situation tu, dan another thing is for us to empathy with other people. Untuk kita, macam kalau kita susah, kita orang yang susah, kita pada keluarga yang susah. The reason why Allah letak kita dalam keluarga yang susah, supaya kita faham perasaan orang susah. One day mungkin kita berjaya dan kita tak akan belittle atau pelekehkan orang yang susah. Macam Nabi Muhammad SAW, dia dilahirkan sebagai anak yatim and a difficult life. Kasih sayang pun dia dapat banyak from grandfather dia, tapi itu pun meninggal. Lepas tu Abu Talib ramai anak dia, dan Abu Talib sangat orang yang susah. So, jadi Rasulullah SAW sangat faham perasaan anak yatim. No, kalau any of you here anak yatim ke tak, kalau you anak yatim, you understand. So it means that when you understand, you're supposed to help others yang dalam the same situation, if Allah gives you nikmat after that. So itulah, so apa-apa yang kita go through is actually good, and it will be a it will be a bonus for you in the future. So one day it will help you. Kesusahan tu one day will help you. So while you're going through kesusahan tu, you need to be patient and go back to Allah. Tu je jalan dia tak ada jalan lain. So belajar pun susah is good, because later in life you will face more difficulty in life yang lagi susah. So all these are trainings for us to become a better person. Okay, so kita hari tu we stop at early effect, right?
Yes, madam.
Okay, good. So now we are supposed to go to the rest of the slide. Let me see if I can open. Share my screen. Fortunately, Windows ni dia boleh juga share screen dengan iPad. I think they have upgraded. Dulu macam MacBook dan iPad dia. Okay, you can see, right? Nampak?
Yes.
Boleh, madam.
Soalnya desktop saya ni besar. Tak boleh istilahnya. trying to make it small. It's not. Okay. All right. So okay, early effect. We've done early effect. You know what's early effect. You should be able to explain early effect. Okay. Now next is we want to talk about breakdown. Okay. So breakdown voltages. We PN junction have breakdown, also breaks down. Because BJT consists of two PN junction back to back, it also can experience breakdown. And the concept of the breakdown in the BJT is very similar to PN junction, but they're just a PN junction. So breakdown voltage breakdown only occurs in the reverse bias. So if it's a forward acting mode, it means that the base to collector junction will experience breakdown. Base to emitter junction tak lah, because it's forward bias. So if this if this what do you call it, BJT, the transistor, you have the emitter, you have the base, you have the collector. So the breakdown will occur here, right? The base to collector junction. Okay. First, let's look at the SVCB or VBC or VCE increases. What happens is the depletion region, because we increase the reverse bias, so the depletion region will also increase, become bigger, and it will spread into the base region. As we discussed before, the effect, okay, so it will increase the depletion region such that then it will have a early effect. So breakdown also happens at that junction where the depletion region will continue to get bigger. The one thing that we don't want it to happen is what we call it the punch through breakdown. Punch through breakdown. This very rarely happen, but it can happen. If the depletion region here, okay, keeps on increasing, what happens is there will be one time that the base will be completely depleted. Okay, the base can be completely depleted such that the depletion meets the depletion region of the forward bias. Yang base tu kan kita ada depletion region here as well for the base to emitter junction. So if this base region completely depleted, it means that dia akan macam depletion region tu dia bersambung continuous from the emitter directly to the collector. Okay, the base is no longer there because they've been depleted. And if that happens, so the collector, the emitter will touch. Okay, touch meaning dia ada depletion region tengah tu, base tu dah habis semua depleted, then you have collector dan emitter, and the collector emitter is touched based on the connected by the depletion region. This is called the punch through breakdown, whereby suddenly you will see a lot of current in the device. Kita tengok ada tak ada. Okay, if you see here, okay, this is the normal graph that we see. So this is the IC versus BEC into PNP. Sama je, dia tukar je BCE. So this is the normal curve. Breakdown region is region B here. Okay, can you see suddenly, patutnya dia straight macam ni ataupun dia increase with the slope. Suddenly there's a abrupt increase in the current. Okay, and this is when you see anything, you do experiment, and then you see this, it means that it's already breaking down. And this breakdown, is it damaging or no? Who can answer? Is it damaging to the BJT or no, this breakdown? Anybody want to answer?
Die what?
Die? Mati?
I didn't hear the question.
Is this the question is the breakdown here? Is the breakdown here damaging to the BJT or not? Who wants to answer?
I think yes,
Why?
because we already make the depletion. Macam ni, there are two breakdown that will not cause damage to the BJT that we learned before. The one that called the avalanche and the satu lagi Zener breakdown and avalanche breakdown. But this kind of breakdown, I think will cause damage because it already exceed what it's supposed to apa? Because the current flow already exceed the maximum current that the
So do you think the avalanche and the Zenith breakdown, the current doesn't exceed?
the current exceed, but it's on the safety measurement. masih selamat lagi lah untuk dia lalu, tapi but for this kind of case the current already exceed the safety.
It triggers me to ask you, what do you mean by safety?
The maximum current is allowed to
How do you know if okay. Okay, let me tell you, maybe when we discussed it last time, we didn't discuss about this breakdown. In the PN junction, we have breakdown of the Zener and avalanche. Is it reversible or no? Is it reversible or no? That breakdown.
For Zener, it's reversible. For avalanche, no.
Okay, that's answered by Afiq. The rest of you? What do you think? Nick, what do you think, Nick? Oh,
Madam, what do you mean
Sorry,
by
madam.
reversible?
what do you mean by?
Reversible.
Meaning reversible means that you can go back to the normal operation of a
Oh,
machine.
okay.
So Nick, what's your answer?
Madam, I couldn't hear clearly because I am lagging just now.
Okay, Mohaimin, repeat the question.
Does the Zener and avalanche breakdown is a reversible process? Is reversible.
What do you think? Nick?
I am not sure.
What do you think? Answer. Whether you're sure or not sure, you answer. In the exam, you have to answer whether you are sure or you're not sure.
Maybe reversible.
Why? Why you say both are reversible, you say? Zener and avalanche is reversible, you say? Internet dia problem. Kita tanya orang lain lah, internet okey sikit. Munirah, what do you think?
I think like what Afiq said that the linear is reversible but not for the avalanche.
Why you say so? Awak tiru Afiq ke memang awak rasa macam tu?
Saya rasa macam tu sebab for avalanche the because the impact ionization, right? So impact ionization we create more and more free carrier and it will not be reversible. And for the Xenia is about the tunneling happen through tunneling, right? So I think tunneling did not affect on the number of electrons, so it can be reversible.
Azimuddin.
I think same as Munira. At Ziner diet, we use high doping material.
Okay, thank you. Enough. Anybody answer other than what their answer is? So ni answer both. Maybe I don't know. In the end kita dah tak dengar dah ujung-ujung dulu. So but there are mainly two answers. One say Zana apa reversible, avalanche not reversible. Ni answer both reversible. I think he answered. Anybody have answer other than these two?
Me, madam.
Anas.
What I think is Xena is unreversible because it affects in the material itself. There is a high doping in there, so it will not act like a normal diode. But in avalanche, it only it only affects the built-in voltage. So if we remove the built-in voltage, the level will be the same again. That's what I thought.
Okay, so Anas' answer is opposite to Afiq Munira's answer, right? Wow, we have various answer. Yang mana betul ni? The rest of you anybody answer other than these three answers? Tak ada. You sure? Okay, if you are sure, all of you are wrong. All of you are wrong. So, so issues maybe you don't understand the breakdown. Okay. Breakdown. Breakdown. What is breakdown? Mai jawab soalan saya. What is breakdown? Mirza Ashraf.
Breakdown breakdown happen when there is a sudden rush of current
So
at certain voltage.
Sudden rush at a certain voltage. How do you get breakdown? How do you get the sudden rush? It means that you have
Flash current.
Yeah, how do you get the flash current? What is current?
What, madam?
What is current?
What is current? Alamak. What is current
What is current? Tak boleh jawab tu, kita balik ke first day balik lah. First day of slide. Siapa nak bantu what is current?
Flow of electron.
Mau jawab flow of electron? Betul ke? Amirul Faris, flow of electron, current.
Yes, madam.
Yes. Anas, betul ke?
Saya ke, madam? Dia terbalik daripada flow electrons, dia flow of holes kan. Dia direction dia. Tak tahu.
Aduh, kelakar semua ni. Afiq, what is betul ke current is flow of electron?
I'm not sure. I give the same answer, Mohaimin. Wait. I think it's wrong. It's flow of charge.
Okay, flow of charge. Explain. Kita buat electrical, electronic all of you, right? ECE, yakin. Wow, kalau orang tanya nanti, habis kita tak boleh jawab.
I'm not sure.
Aduh, so siapa? Haris, bantu kami. Madam, I would like to turn off the camera. Okay lah.
The answer is, I think it's right, but is it partially answered?
Okay, so if it's partially answered, what's the full answer?
Charge per rate of flow of electrons.
Okay. What are awal-awal kita kata, what are the two type of carriers inside semiconductor?
Electron and hole.
Electron and holes.
So can you have a current due to electron?
Yes.
Can you have current due to hole? Yes or no? There's no electron, only hole. Can you have current due to hole?
I think no.
Oh, Mirza, the expert says no. Huh? Macam mana ni? Ni basic ni kindergarten ni. Macam mana ni? Ya Allah. Risau dah nanti mari EAC tanya. Oh, tak jawab. Can we get current due to hole only? Siti Farhana.
I think no.
Azian?
No.
Kenapa no? Why no?
I think current is due to the flow of electron and hole.
Awak ni kan kita dah bincang panjang lebar about diffusion kan. There are two mechanisms what we talk about in semiconductor. The two main current mechanism. One is diffusion, one is drift. And if you look at the slides that we covered, actually for the diffusion, there are two types of diffusion current. One is due to diffusion current of electron and diffusion current of hole. Drift pun macam tu. So you, in order to find the total diffusion current, you have to add the two diffusion current, the diffusion current due to electron and diffusion current due to hole. So how can you say there's no current, hole cannot give current? Mana? Faham tak? But we have two types of carrier charge. Afiq cerita tadi, two types. So each one will give rise to its own current. So that's why BJT is complicated, because the current is due to both electron and hole, which we the one that we draw in the BJT, right? The one we draw that moving is the electron. However, this in the same time there's also hole current. Tapi kita tak cerita. It's just the opposite. But the base current, if you remember the base current of a BJT, how do you get the base current of BJT? Anybody can remind us again? Tak boleh, madam. Otak saya dah jam. Saya banyak sangat assignment dengan quiz. Midterm lagi. Ya ke? Kalau tak boleh, ini sikit je saya ajar ni. Tak banyak pun dalam semiconductor ni. How do you get current in base current in BJT? Kalau tak ingat istighfar banyak-banyak. Semua istighfar 1000 kali hari ni. Banyak sangat dosa kot. Asyik lupa ni. How do you get diffusion, base current in BJT? Nabiha.
The hole that we get from the external wire from emitter.
The hole that we get from external wire. Why the hole comes in?
Because we want to, because at P we have a recombination, right? So we want to produce more holes so that there will be recombination again.
Yes, because we are losing holes due to recombination. Therefore, for equilibrium, the state will always want to replenish. Dia kena sama. It will try to stay the number of holes that being recombined. The circuit will try to make it the same, so that it's in equilibrium. So that's why you have the base current is normally is mostly due to hole current. Okay, the hole are being supplied. Okay, now kenapa dia cerita ni tadi? Lupa dah. Why we go for this?
Breakdown.
Breakdown.
Breakdown. Okay, breakdown. Kenapa tadi kenapa electron? Okay, it's what all of you answer wrongly.
Avalanche and Zener.
Avalanche and Zener. Okay, brothers and sisters. When you have a breakdown, what does it mean? It just means that you have extra free carrier because we go for current. So suddenly rush of current. What is current? Current is actually flow, rate of flow of a charge, electron and hole pair, right? So you have both the electron and hole current separately moving in different direction. So it means that you have extra free carriers. If we stop these extra free carriers, is the breakdown stopped? If we stop, when we don't get this extra free carrier, therefore the breakdown stops, right? Right? The free carriers, does it affecting the bacteria yang macam tak tahu siapa jawab, Azian ke mana jawab tadi? The free carrier, because breakdown means you have extra free carriers. It doesn't say anything about the structure of the material. It's just you have extra electron in the hole. You get breakdown. The name is breakdown because you have sudden rush. But it doesn't change the structure of the material. Material sama je, but we have extra free carriers inside. So now the question is, if we stop the extra free carrier, right? Meaning that if we stop the reverse bias. Tadi kita reverse dia kepada 1000 volt, or no, 500 volt, you have breakdown. Then we go back to 1 volt. You will still have breakdown or no? 1 volt forward bias. Or 1 volt reverse bias. 1 volt reverse bias. Confuse awak. Kita go for 1 volt reverse bias. Daripada 500 tu tadi breakdown lah. Lepas tu saya change voltage dia jadi 1 volt. What do you think? You will still have breakdown or no?
No.
No. Why no? Why no? Nabiha?
Because we decrease the barrier.
So?
So
that you need to come back to what is breakdown. Breakdown is you have a lot of free carriers, right? Now, I reduce the voltage to 1 volt. So what happened? It will stop the free carriers from happening even for Zener. Zener tu dia high voltage, right? Can you see dia punya ni slope dia macam tu. So kalau 500 volt it will be very steep. You have impact ionization. Now I reduce to 1 volt. It means that the slope become less steep, right? When the slope become less steep, it means that there's no more impact ionization. Right, the one who already ended it no longer, because you cannot have impact ionization because the electrons are going with a slower speed. It will not hit another atom to release electron hole pair. Therefore, you will not get free electron hole. Therefore, you don't have breakdown. Therefore, avalanche breakdown is reversible. Zener breakdown also irreversible. You reduce the voltage, then it works like normal diode back. So actually, the wrong understanding of many people out there, termasuklah mungkin lecturer yang bukan bidang ni, they think when it's breakdown, it's a catastrophic breakdown. No, once it's breakdown, you can go back to a normal operation. That's why photo detector, group photo detector who do avalanche photo detector, they work in the avalanche field because they boleh balik pada normal diode balik. They can go back to the normal diode, they can go to avalanche. Go to normal diode balik, go to avalanche. You just play with the voltage. That's the beauty of it. Okay. There is apa nama ni, another type of breakdown where breakdown yang memang rosak, damage the diode when the current is too high that it melts down the structure of the material. Okay, so meaning that if it melts out when the temperature is too high. Current can be very high, but if the temperature is cool down, no problem. But the problem is if you get high current, you get I squared R, heat. And this heat will damage the, what they call it, the material, then they akan terbakar, right? Because it's too hot. And that is when it's no longer reversible. Dia dah rosak. Okay, boleh ada soalan? Semua faham?
I
Yes.
got a question. So
Yes.
so basically, the difference between avalanche and Zener is basically is it because of the resilience of the material? Like after certain voltage, then if the material is not degraded completely, which means it could be reversible. I'm a little bit confused on that. Because previously I thought avalanche is a breakdown that would affect would completely broken because of the chain.
No, the impact ionization, the chain reaction doesn't, it just increase the number of free carrier. It doesn't damage the structure if the temperature is okay.
But then how because it hits off the electron
Okay.
from the.
It hits, so your understanding when it hits, it damage, right? That's what you're thinking?
Yeah. I mean, my understanding was like when it hit, it could not go back to you know the
Let me draw.
electron.
Let me draw to you what does it mean by heat. Okay. So heat dia kena faham heat atom tau. Heat atom yang saya draw je. Okay, now I can see where you confused. So if you don't ask me, I don't know kenapa you tak faham. Bagi saya macam senang je. Okay. Right. So let me draw here. See here, right? So kita ada ni. This is the atom, right? And the electron is here. Okay, so in impact ionization, there will be an electron or hole, okay, which are moving very fast. Why? Because the electron are drifting very fast. Okay, because of the slope with high kinetic energy. So this electron are moving very fast, and now it hits. And now it hits the atom. When I say it hits the atom, it hits the atom, this electron, the bound electron, which actually, if you draw the band, connection band, valence band, when it hits the atom, which is this, the blue electron is actually here. Now the red electron are hitting the blue electron, giving its energy. When they hit though, they pass energy. Okay, so it pass the energy means that this electron, the blue electron now, gaining extra energy, and it can go to the conduction band. So it become a free electron. That is impact ionization. It only hits the electron. Electron is not the structure. Electron is just the electron. apa kata dia, pusing-pusing in the atom. It's not the structure, the nucleus. So nucleus still the same. So that's why it doesn't change anything. It doesn't rosakkan. It doesn't apa nama ni, change the structure of the material. Does that answer your question?
So do you mean like when we reduce the number of carriers, then it slows down, the chain reaction would stop, and then the remaining holes and the electron would
Will be
would
collected, and then go to the outside circuit.
I see. I see. Okay, I understand now.
Because say reverse bias or avalanche, you need to measure, right? When you measure, it means that it will go out of the apa nama ni, the device. It will go to the external circuit.
I see. That explains.
Okay. Any more questions?
Madam, I want to ask. Madam.
Yes.
So if we make the voltage is too high, will the Zener avalanche damage the material?
Okay, Iqmal.
Yeah, because you said just now.
I said just now.
Because you said just now when the current is too high, and then it will damage the material. So if we make the voltage for the both breakdown, Zener and avalanche, it will create a damage, or these two breakdown will not create damage to the material.
Okay, thank you for the question. Iqmal answer.
The breakdown, the damage will occur when the material have the high temperature only. It doesn't matter how high the current. That's what I understand.
Does that answer your question?
I'm not sure.
Do you understand?
Yes. So it will damage the material if the temperature is too high. Not because of the voltage. Is it?
Iqmal answer.
From what I understand, I think the voltage does not give any effect. Only the temperature will damage the structure of
But
material.
if the voltage is too high, will the temperature high also?
Answer.
Yes.
So?
It will damage, I think.
So, are you happy with the answer, Azian?
I think so. So it will damage.
So the answer is yes, because if you increase the reverse bias voltage, it will increase the current. So when you have current, remember we talk about the other mechanism that happens when you have a lot of current at high voltage. You have a lot of scattering. Kan kita belajar semua benda ni kan. So that's why all this knowledge you need to, when you answer in the final exam, you cannot use all the knowledge in isolation. You need to gather everything that you understand to answer one problem. So okay, so you need to answer that, there will be other mechanisms that in the end you have no choice other than, if you increase the reverse voltage, it will increase the temperature. If it increase the temperature, and if it's too high, it will damage the material, therefore the device. Okay. Kalau dalam exam nanti jawab sedetail mungkin, apa yang awak faham daripada semua of the semiconductor masukkan, then you get marks. Kalau tak, saya akan tolak. Kerja saya bagi awak full mark, tak cukup data saya tolak. Hingga tak tahulah tinggal apa kan. Soalnya make sure that you write everything that you think is plausible. Okay, sebab tu dia kena berfikir lah. Alright, any more question on this breakdown? So the punch through breakdown, so both of the breakdown are reversible. The punch through breakdown also reversible if we apa nama ni, tapi punch through breakdown ni dia reversible bila kita kurangkan voltage dia. It means that when reduce the voltage, it means that the depletion region becomes smaller, therefore everything goes back to normal again, right? Okay, unless the temperature is very high, then it breaks down. Okay, okay. There are other types of breakdown which I will not cover in the class. Dia ada, kalau you look at the slide, there are different other breakdown, but I won't cover here. So what are the apa nama ni parameters that affect the breakdown? 5 minit. What are the parameters that influence the breakdown? Is the base width, how big the punch through, right? So that if the base width become, remember we want the base width to become small or big. When we design the BAT, we want to make it small or big, the base width.
Small.
Yes. Why you want to make it small?
We want apa ni IB to be small.
Yes, you want to be very small. But if you make the base width small, is it good for the breakdown?
No.
No,
Why not?
Because
because
breakdown. Jawab.
Yeah.
Because breakdown can happen easily if we increase the voltage.
Yeah, can happen easily.
Can apa? Because of the depletion region, it will easily apa panggil? Apa nama dia?
expand.
Expand.
Expand and deplete through.
And short.
Punch through. So maknanya that's why always when as an engineer, when we design something, there's not always the ideal situation. You do this, they affect this. You do this, affect this. So in the end, you have to find the optimize. That's why kalau apa-apa kita kata optimization or the optimized design. So we want the base current to be low. However, we don't want to, so we need to find which. That's why sometimes we do simulation. In IC design, we do a lot of simulation before we make it to ensure that in the end, apa nama tu, we don't we do it and it's a waste of money. So base width affect. Material being used also affecting different material, semiconductor material have different impact ionization coefficient. Dia ada nama dia, impact ionization coefficient. A lot of people research has been done to find this coefficient. So different material, you can Google lah benda ni. Different material have different impact ionization coefficient, which means that the rate at which it will go to breakdown also different. Okay, so kadang-kadang if breakdown is very important, we need to choose the right material. Doping level. So as Zener, for example, Zener breakdown, is very affected by doping level. So sometimes we want to dope it very high. So for example, the collector, I don't know, for somehow you want to make it high, but it may affect the breakdown. And in the end, biasing voltage. Of course, right? The more do you reverse bias, the higher the chances for you to get breakdown. So that's the parameters that affect the breakdown. As I mentioned, I'm still doing the final exam question. You have design question. So you need design question means you have to use all your knowledge and put inside the design. Okay, another thing is thermal effect. We have 2 minutes. Thermal effect is we already discussed this partly in breakdown. Breakdown for it to when it's catastrophic, when you have thermal runaway. Thermal runaway is when dia terbakar, it's burned. because there's a positive feedback whereby it keeps on making it worse and worse. For example, because as we know, semiconductor devices are very sensitive to temperature. That's one of the downside. That the designer need to always think how does to make sure that the temperature doesn't affect the performance of the device. So because if you change the temperature, it will change the carrier lifetime and diffusion coefficient and many other parameters. So therefore, so tak percaya slide saya ni. Basically, thermal runaway just means that you apa nama ni, you have the current keep on increasing because of the mechanism. For example, if breakdown occur, meaning you have a lot of current. When you have a lot of current and you know P equals to I squared R, it means that it will be double, right? Because not double power, kuasa square. So it means that when the power is high, it means the temperature will also increase. Okay, when temperature increase, what happens to the other carriers? Can we know we have conduction band, we have valence band. When temperature increase, this many more electrons will be excited. If it's not even avalanche, if it's not even impact ionization, you can still excite the electron through other mechanism, which is the normal mechanism. The electron will be excited. So it gives, on top of the impact ionization, you have extra ni, carriers due to excitation of free carriers due to temperature. And that means that again, the temperature here, the I squared R here will increase, the power will increase, dari macam feedback yang tidak bagus. It was very quickly spiral until the temperature is very high and you cannot control it anymore. Thermal runaway is when you cannot control it anymore, the temperature keep on inducing more free carriers. Even if you reduce the voltage at that time, the damage done already, the temperature is too high, because it's not easy to reduce the temperature very fast. Voltage you can reduce up, you just with a knob you can reduce the voltage, but temperature is still there in the device. So if the temperature is still there very high, and the temperature is very high, cannot be controlled, a lot of electron or free carriers are being generated, you might have this thermal runaway. Thermal runaway means habislah, burn. Sometimes can remember in your first year you do experiment and suddenly smoke comes out. Right? I don't know whether you experience or no. I've done it many times. Many died in my hand because of this thermal runaway. There's too much current. Okay, I think that's all for today. Next week we'll continue with the base resistance and emitter crowding. And the Kerr effect, I will give you the video of the last time in the class to watch on the Kerr effect, because it's complicated. I want you to watch that. So maybe for next class, inshallah. All right. Any question before we end? Lepas 2 minit lah. Awak ada kelas kot yang lain. So kalau ada soalan, you just text me lah. Okay. So can we? Awak dengar kan saya bercakap masa the
Yes.
Yes, madam. Yes.
So can we end with doa, please?
Me, madam.
Silakan.
Auzubillahi Bismillahirrahmanirrahim. Alhamdulillahirabbil alamin wassalatu wassalamu ala asyrafil anbiya'i wal mursalin wa ala alihi washabihi ajmain. Bismillahirrahmanirrahim. Hasbunallahu wa tawakkalna ila Allah ittasamna billah fadana amina ila Allah masya Allah la haula wala quwwata illa billahil aliyyil azim. Allahumma ayyina bil iman wa amisna bil iman wa shilna bil iman wa adina jannata ma'al iman. Sallallahu ala sayyidina Muhammad wa ala alihi washabihi wa baraka wa sallam. Subhana rabbika rabbil izzati amma yasifun wa salamun alal mursalin walhamdulillahi rabbil alamin.
Alhamdulillah. Thank you, Brother Muhammad. Let's close the class with tasbih kifarah and salam. Subhanakallahumma wa bihamdika asyhadu an la ilaha illa anta astaghfiruka wa atubu ilaik. Bismillahirrahmanirrahim. Al-'asr innal insana lafi khusr illa alladhina amanu Can I give the quiz next week? Saya janji berapa 4 quiz kan?
The BJT quiz. Is it?
The apa ni? The optoelectronic kan? Quiz. 2 device, sebab 2 akan masuk exam, 2 lagi masuk quiz kan?
Yes.
Boleh ke tak boleh? Are you full? Tapi tak tahu. Thursday?
Boleh madam, boleh. Kuis bagi yang senang madam. Kuis bagi yang susah, untuk. Madam bagi yang senang.
Ya ke?
Boleh lah madam, boleh lah.
Kalau kuis senang saya bagi final exam susah lah. Okay?
Tak nak.
Kalau kuis susah boleh tolak satu kuis.
Itulah kalau kuis susah. Betul.
Bijak.
JT kuis senang sikit.
Saya rasa tak susah. Susah ke?
Yang penting laser quiz madam, laser quiz.
Laser akan
Itu
masuk.
betul.
Laser masuk quiz ke? Okay, laser yang akan masuk final siapa? Solar cell dengan apa?
LED.
Foto.
Ya. So dengan photo detector kan?
Untuk
Nanti LED dengan laser jadi quiz lah.
Boleh juga tu.
Tak pun tak sesuai lah photo detector dengan saya rasa LED.
Boleh kot madam sebab foto detector reverse. Lepas tu LED kan forward.
So laser masuk quiz. Photo detector masuk final. LED masuk final. Solar cell masuk quiz. Okay. So alright. So ni awak ingatkan saya. So kena tunggu sebab saya nak buat soalan ni. So okay ni final. Photo detector, LED, quiz, solar dengan laser. So be prepared for next week.
Quiz BJT tak ada kan madam?
BJT satu lagi kan?
ada 2 quiz lah.
Ada 2 lagi quiz. Ada satu ni dengan satu lagi. Okay?
So next week yang yang Oktober.
Laser dengan solar cell.
Okay.
Next Thursday kan madam?
Awak nak Tuesday ke Thursday?
Thursday.
Thursday insyaAllah. Okay?
Okay.
Alright. Okay, jumpa next week. Okay,
Terima kasih
Thank
madam.
you, Doktor.
Waalaikumsalam warahmatullahi wabarakatuh.